we have, so I'm going to use f sub x, which is, okay, so I'm going to rewrite, okay, so I'm going to rewrite m of xy equals the partial derivative of f with respect to x equals x cubed plus y cubed, okay? So if I want to find out what f is, I just need to integrate both sides. And when you integrate both sides, so from here, when you integrate the left-hand side, you get f of xy, because when you integrate, you cancel out the derivative. But on the right side, it's going to be the integral of that with respect to what?
Trying to do this shit.
Can you tell me?
dx.
With respect to x. Very good. Because the derivative is the derivative with respect to x. So if you integrate both sides with respect to x, you get rid of the derivative, you get f. On the right side, you have this, right? So, okay, so listen to this carefully. When you integrate with respect to x, when we integrate with respect to x, we are treating the y as a constant. Do you agree?
Yeah.
Okay. So if that is the case, then oops. Then on the right-hand side, what is the integral of x cubed?
X bar 4 divided by 4.
X to the fourth divided by 4.
Right.
Plus, what is the integral of y cubed with respect to x?
Y cubed
Y
x.
cubed x.
Y cubed x. Very good.
Yeah.
So we write x y cubed plus a constant. Do you agree? This constant must contain or could contain what? It's not just a constant c, okay? Because you are integrating with respect to x, so y is considered a constant. So whatever the constant is, that constant might contain y in there. Are you following that? Because y is considered a constant, so whatever your constant is, it could have y in there. Okay, so make sure you understand that. Okay, so instead of putting a plus c, we say it's gonna plus a constant containing y. Okay, so you make a note of this. So this is a constant. Is a constant containing y. Okay, so if you were to integrate with respect to y, then the constant is going to be a function of x, because x is considered a constant. Okay, so it's important for you to know that. All right, so we don't get the f of xy yet. Okay, because we don't know what this is, so we have to find out what that is. Okay, so now let's go to the next step. So now find the constant. G of y. Okay, so how do we do that? Okay, now remember, whatever this function is, when you take the partial derivative with respect to y, it must be the same as this one up here. Okay, it must be, because this is the partial derivative with respect to y, so it must be that. Okay, so this is what we have. I'm going to take this one down here so you can follow. Okay, so so the partial derivative of that with respect to y okay is what? What is the partial derivative? So it's going to be the partial derivative of x to the 4th over 4 plus xy to the 3rd power plus g of y. Okay. And what is the, and whatever that is, it must be equal to n of xy, because n of xy is the partial derivative with respect to y. Okay. All right, so let's find out. Okay, so for this one is 0. What is the derivative of that with respect to y?
1/4 xy to the 4th.
You just integrated. You didn't
by
put it.
Q.
Oh, sorry.
So be careful. Okay.
3xy
It is
squared.
a common mistake. Okay, so it should be
3xy squared.
3xy squared.
Sorry about that.
And then this is a function of y only, right? Because it's g of y, so it doesn't have x in there because it is a constant in containing y. So this is a function of y. So when you take the partial derivative of this with respect to y, that is actually g prime of y. So now it's just a regular derivative, because you know that this function contains only y, and you are integrating with respect to y. So when you write g prime of y, then it is understood to be the derivative with respect to y, or just like dg dy on the bottom. Okay. Now on the right hand side, what is n of xy? Right there, n of xy. Right, so that's 3xy squared. So this is 3 of xy squared. Okay, so from here we know g of y is equal to 0 because these two cancel out. So if g prime of y is equal to 0, then g of y, so in order for you to find g of y, you just integrate both sides, right? And when you integrate both sides, with respect to y, of course. Okay. You integrate both sides with respect to y. So the integral of 0 with respect to y means, what is that equal to? The derivative of what is 0?
A
Regular
constant.
It's just a constant, right? So it is a constant, c. Okay. Because if you take the derivative of c, you get 0, so you get back.
I have a question, Professor.
Yes.
So right under the red arrow, you actually meant to write Fy, not Fx?
Right under the F.
Right under the red arrow.
first
This
line of
one
one of
right
the
here. This one. Oh,
one more down.
yes, right here, right? Yeah.
Yeah.
I meant the partial derivative with respect to y. So this is supposed to be y. Thank you so much.
Okay, thanks. That confused me.
Okay. Yeah, that is the partial derivative with respect to y. Okay. So, but I'm gonna say g of y is equal to c sub 1, okay? Because there's another constant involved. So I just write c sub 1. Okay, so now you know. So f of xy is equal to, like from up here, see from up here, is x to the 4th over 4 plus xy cubed plus g of y. So that means plus that's C sub 1. All right. So the solution of the differential equation, okay, is f of xy equals a constant. Do you agree? I'm going to call this constant C sub 2, okay, and you will see why in a minute. So you know that when you solve an exact equation, the solution has to be the function f equals a constant. And then you know that the function f on the left-hand side is x to the 4th over 4 plus xy cubed plus C sub 1, okay, equals, and then on the right you have C sub 2. So that means the solution is x to the 4th over 4 plus xy cubed. I moved the C sub 1 to the right, okay, so I moved the C sub 1 to the right. Then on the right side, I have C sub 2 minus C sub 1, which is another constant, C, okay? So therefore, I'm writing a lot here, but you know, when you do your homework, you don't have to write as much as I do here, because I'm trying to explain to you everything I can. So the solution is x to the 4th over 4 plus xy cubed equals a constant.
Mr.
Okay.
Koch,
Yes.
is this a technique under a different name in multivariable calculus? Because I recognize the sort of steps.
Yeah, this right here is multivariable calculus.
Yeah.
Up here. Yeah, the stuff that we did up here.
Okay, just making
Yeah.
sure.
Yeah, so now we're just doing the reverse. So the reverse is differential equations, okay? So this technique is called solving, we just say solving an exact equation. That's all we call it, okay? So far we've learned how to solve by separating the variables. We learned how to solve by using an integrating factor. And now the third method is solving an exact equation. So the method that we are doing here, you can only use this if the differential equation is an exact equation. If it is not an exact equation, you cannot do it the way we just did, all right? So if it is not an exact equation, then you have to try to rewrite the differential equation and to see if you can separate the variables, or you see if you can write it in standard form, so you can identify the p of x. Then you can use an integrating factor. Okay, so there are different ways here. So say on the test or on a quiz, if I just say solve this differential equation, that means I allow you to use any method that works to solve the equation. But if I specify a certain method, make sure you use that method to solve, okay? All right, any more questions before I move on to the next one? No? Okay, so the next one, this time you have an initial condition, okay? So this initial condition is like after you solve this equation to get something like this, then you're going to plug this in to find out what the C is, okay? Because this gives you the general solution of the differential equation. But if there is an initial condition, you have to use it to find the C so you can get a particular solution. Okay, so make sure you understand all the terminology there, okay? So for 22, we do the same thing. The first step is we're going to identify the M and the N and see if the equation is exact. So from here, you know, the expression in front of the dx is M, and the expression in front of the y is n. So first step, all right, and you know that that is actually the partial derivative of f with respect to x, right? And n is 2 plus x plus y e to the y. And that is actually the partial derivative of y, partial derivative of f with respect to y, okay? So to be exact, so from here, if you take the partial derivative of m with respect to y, you get 0 plus 1, which is 1. And over here, the partial derivative of n with respect to x is 0 plus 1 plus 0, which is 1. Okay? So since m sub y is actually the partial derivative of x and then of y, right? Okay, but we can just write like this, which is equal to n sub x. Then you know the differential equation is exact, okay? Is an exact equation. All right, so now we can go ahead and use the method that we just used to solve. Okay, so when you do this, it doesn't matter whether you pick this one to find f or you pick this one to find f. Now, if you were to do this one on a quiz or on a test, which one would you use to find f? The m or the n?
Probably M.
The M.
Yeah.
M. Why is that?
Simply.
Simply.
Very good. So make a note of that, okay? You should use m to find f. But however, I'm not going to use m, all right? Because I want to use the n so you see how to deal with that constant, g of y, okay? So just make a note. So now we should use m to find f of xy, okay? But I'm going to use, okay, I don't know why I write all of these down. Use n, okay, so I'm going to use n, and n is f sub y equals 2 plus x plus y e to the y. And now you see why this is harder, okay? So when you do this, you're going to integrate both sides with respect to what to get f?
Y.
With respect to y. So you know that f of xy is going to be the integral of 2 plus x plus y e to the y with respect to y, okay? So what do we have? So let me go a little bit to the left here so we have more room. So f of xy is equal to the integral of 2 with respect to y is, or let's just, okay, let's do it over here. What is the integral of 2 with respect to y?
2y.
2y.
2y. The integral of x with respect to x. With respect to y, I'm sorry.
XY.
xy.
xy. And then how do you find the integral of y e to the y with respect to y?
Equal by parts.
Yeah, integrating by parts. So now you it's harder, right? Well, it's still easy at this stage. That should be easy, but it takes longer than using the m to find the derivative. You see? So that's why you should always use the simpler one to do. Okay. So in this case, so I'm gonna separate this to do some work. Okay. So we're gonna use parts. So let u be y and dv be e to the y dy. Then du is 1 dy and v is e to the y. Okay. So what you have is, so f of xy, so you know the integral is uv minus the integral of v du. Okay, so that's what you have. So what you have is 2y plus xy plus, and then the integral is going to be uv, so I'm going to write it in green. Okay, so uv is y e to the y minus the integral of v du, which is e to the y du, right? No, e to the y dy. Okay. So that gives you 2y plus xy plus y e to the y minus the integral of e to the y with respect to y. So it's going to be e to the y, right? Plus a constant. Okay. So let's add the constant over here. Plus a constant, and the constant is a function of what?
X.
X, yx.
Because X is a
we are
constant.
integrating with respect to y. So we treat x as a constant. Does it make sense? Yeah, so you make sure you make a note of that. Okay, so it should be a constant containing x. Okay. So what's next? So let's just want to follow the same steps. So step number 3 is now we want to find that constant g of x. So step number 3. Now find the constant. G of x. Okay. So to do that, we just bring it down here. We take the partial derivative with, so we know that which is partial derivative with respect to y to get this. So now if we take the partial derivative of this one with respect to x, we better get m sub xy, right? Because that is the partial derivative with respect to x. Okay. So if we do this, we're going to get 0 with respect to x. So the derivative of xy with respect to x is y. And what is the partial derivative of this with respect to x? Okay, let me write this. Let me write like this so you can see.
0.
Yeah, let me write like this. Okay. 2y plus xy plus y e to the y minus e to the y plus g of x. Okay. Like that. So whatever we have here, that must be m of xy, because m of xy is f sub x. Okay. So now let's do this. So that gives you 0. That gives you y. What is that again?
0.
0 minus, how about this one?
0.
0.
0 plus, how about this one?
G prime of x.
G prime of x. Now we'll just write the regular derivative because it's just a function of x. It doesn't have y in there, so you don't use partial derivative, okay? And on the right-hand side, what is this? What is that?
E to the x plus y.
E to the x plus y, right there. See, f sub x is e to the x plus y. All right, so let's see what we have. Okay, so we have a y here and a y here. We can cancel them out. So what we have is g prime of x equals e to the x. So how do we get g? So g of x is just the integral of e to the x with respect to x. So this is just a normal derivative and normal integral because we don't have partial derivative here. So we write like this, right? Okay, so what is g of x?
E to the x.
Just e to the x?
Plus c.
Plus c.
Yeah, plus a constant. So now it's just a c. So I'm gonna write plus c sub 1. Okay. All right. So what did we do after that? Okay, so step 3. So we just say so. Okay. Okay, so write so. F of xy is what? Right there. See, it's 2y, all of this, and then this one is e to the x plus c sub 1. Okay, so it's 2y plus xy plus y e to the y minus e to the y, and g of x is e to the x plus c sub 1. Okay. All right, so implies the general solution is this, right? Which means 2y plus xy plus y e to the y minus e to the y plus e to the x plus c sub 1 and then equals c. So I'm going to write that c as c sub 2, okay? So c sub 2. So that gives you 2y plus xy plus y e to the y minus e to the y plus e to the x. And then you're going to move this c sub 1 to the right. So c sub 2 minus c sub 1 is c. Okay, so that is the general solution. So if we had just a differential equation, then that would be your answer. But because this problem is an IVP, so now we're going to use this one right here to find out what that constant is. So y of 0 equals 1. So y so y of 0 equals 1 implies, that means when x is 0, y is 1. Okay, that's what it is. So whenever as you see x, you replace it with 0, and you see y, you replace it with 1. So I have 2 times 1 plus x is 0, y is 1 plus y is 1, and then e to the first power minus e to the first power plus e to the x, which is 0. Okay, so what do we have? So we have 2 plus 0 plus e minus e plus 1 equals c. So c is equal to 3. Right? So therefore, the solution of the IVP is right here, which is this one. Okay, I take it down here and I write 2y plus xy plus y e to the y minus e to the y plus e to the x equals c, which is 3. Okay. Is this an explicit solution or an implicit solution? Can you tell me?
The implicit.
Implicit solution. Very good. All right. So that is section 2.4. Okay. Any question before we move to the next section? So the process is simple, but you have to really understand. And again, before I move to the next section, a major mistake and a very common mistake that students make in this section is writing the solution. Whatever the function is, then they say, okay, so right here, see, like in example 1, what they normally did, some of it is like after they get the function, right, the general solution, then they say, they box that, they said that's my answer, that is the solution. No, you don't just give me the function as a solution. Okay, the solution is supposed to be a function equals a constant. So right here, so that is supposed to be the solution, and then from here you simplify to get that. Okay, so don't just give me a function and say that is the solution of the differential equation. All right, the solution to the differential equation has to be whatever that function f of xy is equals a constant. Okay, so make a note of that. So that's the most common mistake that students make when they solve an exact equation. And the second mistake is the way they write the constant g, right? So the g of y or g of x. So you need to understand when the constant contains y and when the constant contains x. Okay. Okay, so let's go to section 2.5 now. So 2.5 is another technique of solving first order linear differential equations. And we say we solve it by substitutions. Okay, so there are different ways to substitute. So you just need to know when to substitute what, okay, to get a solution. All right, so the chain rule. Suppose I give you a function z, a function z in terms of x and y. All right, so then what is the what is the derivative of z with respect to x? So the derivative of z with respect to x, so we did that in the previous section, but let's do it again. So if you want to find
Professor?
the derivative of z with respect to x, then by definition in calculus 3, okay, it is the partial derivative of f with respect to x multiplied by that, which is 1, okay, and then plus the partial derivative of f with respect to y, and then multiply by dy dx.
Professor?
Yes?
If you need to blow your nose, you can blow your nose. Like we're okay if you like take a moment.
I'm sorry?
If you need to blow your nose, it's okay. Like you can blow your nose if you need to.
No, I'm okay. Yeah.
Okay.
Yeah, okay. Thank you. I know it's sometimes it's my habit just to share with you, okay, just to share with you real quick because I think we have time. You know, I grew up in Vietnam. I left when I was young, okay, my early teen. But in Vietnam, when we were in class during my time, you are not supposed to blow your nose, not supposed to sneeze in class. So you know, when you come to class and you get sick and you get running nose, you have to go, you wipe, you use your shirt, you wipe. You're not supposed to leave class during the middle of class. So it's just awful, right? And then you're not supposed to sneeze. So I get so used to that because I was so well trained, right? So in here, so when you know, I really want to sneeze, but I said, wait a minute, I'm not supposed to sneeze in class. So you know what I do to stop myself from sneezing? I just squeeze my nose. But then sometimes I squeeze, but I say, wait a minute, I'm in the US, right? Not in Vietnam. So I go, I sneeze, you know. But it's my habit. But anyway, I got this because yesterday for some reason I went to my backyard to work on my generator, and my wife was in the backyard also, and both of us got so bad allergy yesterday. I went out there for 15 minutes. I started sneezing and stuff, and you know, it was so bad. So last night I had to take some Benadryl, right? And you know, when I got up, I was, you know, it's like I was high, you know, I just didn't want to get up, you know, I was walking so in the air. But I took a nap earlier this afternoon after my morning classes, so I was feeling better. But don't worry, okay? After I do some more differential equations, then that's gonna go away. Okay, I'm not kidding. Okay, when I get allergy and I get sick, and when I teach, it goes away. All right. Okay. So if you get sick, make sure you do a lot of differential equations like me. Okay. Okay. So now let's go to this section. So what we are trying to do is we're trying to get the dz, right? So from here, let me just do one extra step in between here. So you know, dz dx is equal to the partial derivative of f with respect to x. Dx is 1. So that is this. So the total differential, that's what it's called, dz. So you just put the dx to the right. So what you have is this. That looks familiar, right? Like if you put this one equals 0, then that is like an exact equation in the previous section. But in this case, it might not be 0. Okay, so you just need to make a note of the dz. So dz is what you see on the right-hand side. Okay, so that is the chain rule that you learned in Calculus 3. Okay, so again, for those of you who did not take Calculus 3, it's okay. You know, this is just like how you would learn when you take Calculus 3 from the beginning. They show you this. Now let's talk about homogeneous functions. Okay. So what kind of function is a homogeneous function? Okay. So by definition, It says a function f of xy is called a homogeneous function of order alpha. Okay, order alpha. If it can be written as, so when you have a function f of xy, if you replace x with tx and y with ty, and then somehow you can factor out the t raised to a power, and it turns out to be like this. All right. So if you can write a function f like that, then we call it a homogeneous function. Okay. So for example, I give you f of xy equals x squared plus y squared. So to see if it is a homogeneous function of order alpha, then this is what we do. We're going to replace the x with tx and the y with ty. Okay, so now if we see x, we replace it with tx. And if we see y, we replace it with ty. And then we try to simplify it. So that gives you t squared x squared plus t squared y squared. And you see both have t squared in common. I factor that out. Okay, so here I have f of tx ty equals t squared. And you know x squared plus y squared is f of xy. So you see, this one fits in this definition right here. So you know that this function is a homogeneous function of order 2. Okay. So therefore, f of xy is a homogeneous function of order 2. Okay. And if a function is homogeneous of some order, we can rewrite the function as follows. Okay, so since f is a homogeneous function of order 2, we can write f as, how we can write it as like this. Number 1, let me see, we can write we can write like this. We can factor out x, and it is all of order 2, so that's x squared, and then on the inside it's like that. Okay, all right. So now, so how do you know that you can write this like that? How do you know that these two are equal? Okay, how do you know that? All right, let's find out. On the left-hand side, you see that that is x squared plus y squared. On the right-hand side, what is it? But first of all, let's highlight this one. Okay, so this is a formula that you can make a note of. Now let's go to the right side and see what the right-hand side is. Okay, so f of 1, let's write f of xy is equal to x squared plus y squared. So if you have f of 1 y over x, then you compare. So here's your function, right? Here's your function. So when you plug in a value for x and a value for y, you just go over here and you make a substitution, okay? So based on this one right here, x is 1, okay? Please pay attention here, okay? So x is 1, y is this one, all right? So whenever I see x from my function, I replace it with 1. Whenever I see y from the function, I replace it with y over x. So x is 1. Y is y over x. And then you simplify, you get 1 plus y squared over x squared, okay? Now you go to, so you know that on the right-hand side here, you have x squared, you have x squared. And f of 1, I'm sorry, it's supposed to be f of 1 comma, okay? Not plus, it's supposed to be a comma. So that is 1 plus y squared over x squared. And you see, if you multiply the x squared out, it is equal to the left-hand side. So I'm trying to show you that this is true if you know the function is homogeneous, okay? Or you can also write the function as y squared. All right. So I'm gonna let you find out why. Okay. So you just verify like how I did it up here, right? To do that. So this is another form. Okay. So the way I remember this is, if I know a function is homogeneous of order 2, then I can rewrite the function as, like, by factoring out the x or the y raised to that order. And then inside, the x that I factor out becomes a 1, and the other one is just y divided by that x. And here I factor out the y raised to that order, then y is 1 now. And then the x is x divided by that y. Okay, so that's how I remember. Okay, so make sure you know the different terminology here, okay? So here we just defined a homogeneous function, okay? And that homogeneous function is like this, all right? Now we're gonna define a homogeneous differential equation, okay? So what is a homogeneous differential equation? So you see the form that we had in the previous section is like this, okay? This differential equation right here is called a homogeneous first order differential equation if both m and n are homogeneous functions of order alpha. So they have the same order, right? So when you have a homogeneous, when you have a differential equation written in this form, okay, then we call it a homogeneous differential equation when both m and n are homogeneous functions of order alpha. So if it is a homogeneous function of order alpha, then this function can be written as t to the alpha times m. That means you factor out the t to the alpha, right? So when you factor out the t to the alpha, then this one is divided by t, this one divided by t, okay? See right here, look. This is a homogeneous function. So you factor out the x to that order, then you divide this one by x, you get 1, you see? And you divide this one by x, you get y over x. And then same thing here. See right here, it's a homogeneous function of order 2. So if you factor out y squared, then you divide this one by y, you get that. Divide this one by y, you get 1, all right? So let's see if you can tell me what we have here. So this is a homogeneous equation of order alpha. So we factor out t to the alpha. So we divide this one by t and this one by t. So what do we have? M of
X and Y.
x and y. Okay. All right. Or, but you know that M is a homogeneous function of order alpha. That means from here, I can also factor out x to the alpha. So here I get what? What do you do to this?
1 and y over
Divide by
x.
x, you get 1. And then divide this one by x, we get y over x. Okay. So that is going to lead you to something. I'm gonna go back to that. Okay. So just leave it blank for now. All right. Because that's going to help us determine what kind of substitution we should use. Now, same thing right here. You have n of xy. And right here is going to be n of x over y 1. Okay. So you might ask, why do we need to do this? Why can't we just use the stuff that we just learned in section 2.4 to do this, to solve this equation? You can't. Because in section 2.4, the only way you can solve like the way that we just learned in 2.4 is when this equation is an exact equation, okay? Because if the equation is not an exact equation, you cannot do the way that we learned in 2.4. It looks exact, but it might not be. So that's why I told you in 2.4 that whenever you solve by using the method of exact equation, you first prove that the equation is exact. Because if it is not exact, you cannot do it. So if it is not exact, we learned the stuff from section 2.5 to deal with that, okay? So if it is not exact, then when you get to this one, then this guy right here is going to help us determine what kind of substitution we need to use. So if you have this, then we're going to let this one be u, okay? So we're going to let that be some function, u. So u is going to be y over x. Okay. And then for the second one, you can use u or you can use v. Okay, just say use v, so you know they are different. That's all. So you can say, I'm gonna let v be x over y. Okay. So once you have that, right? Once you have that, so note, u equals 1, y over x implies y is equal to ux, right? So y is equal to ux. So y is a function. So y is a function of a product of two functions. So the derivative of y is what? So the total partial is dy. So from here, dy is u dx plus x du. All right. And then the second one, v equals x over y. Then we can write that as dx is v dy plus y dv. Okay. So far, so good. Okay, you just use the product rule, right? The derivative of y with respect to x, right, is u times the derivative of x plus x times the derivative of u, and then you just multiply the dx over to both sides. Then you get dy, and then this times dx, and this has the dx on the bottom, and you multiply the dx, you cancel out. Okay, so that's how you get those. Okay, so there are two ways you can make the substitution, right? You have this, and you have that. So how do you know which one to use? So here it says, if m is simpler than n, then you use the x substitution. Remember, the way I remember is I use x for m, I use y for n. How do I know whether it's x or y? You see, if you look at the differential equation, the m corresponds to the dx, the n corresponds to the dy. So if the m is simpler than the n, then I'm going to make my substitution as x equals, right? Because it corresponds to the x. You see, that's how I remember. So when you learn something like this, you have to figure out a way for you to remember things easily. Okay. So that's what I use. So if the m is simpler, I use my x substitution. If n is simpler, I use my y substitution. And when you do an actual problem, you can just say x is equal to uy, or y is equal to ux. Okay, so you don't have to use u and v, but I just do this to indicate that they are just different. Okay. So when you make the substitution, then let's say if you use this substitution right here, then your goal is to find out what the v is. So if you can get the v, then you will get your solution. So let me demonstrate that with this example right here. So solve the differential equation by using an appropriate substitution. I'm just curious, okay? Let's see if this is an exact equation. This is m, right? So when you find the partial derivative with respect to y, what do you have? What is the partial derivative with respect to y?
2y plus x.
Very good. And then the partial derivative of this one with respect to x is
2x.
And they are different, right? So you know that the partial derivative of y here is different from the partial derivative with respect to x here. So they are different. That's why this equation is not an exact equation. Okay. Therefore, we have to solve this one by using an appropriate substitution. Okay. So first, here is given, and you can prove it. Show that m and n are both homogeneous functions of order 2, just like how we did it up here. Okay, that's how we show that, right? You can do the same thing for m and for n, and indeed they are homogeneous functions of order 2. Okay, so now let's say that you went through all of that, and then now you can make a substitution. And since n is x squared, it is simpler than m, right? Then we're going to use what kind of substitution? N corresponds to y. So we're going to make the substitution as y equals what?
ux.
Ux. Okay. So that is the substitution that we want to use. And now our goal is to substitute it in here and then find out what u is. All right. So let's plug it in. So instead of y, we're going to replace it with ux. Okay, so I'm going to write. So y is ux. Y is ux. Oops. I like to use red when I make a substitution. And then dx. So when you make this substitution, that means you don't want to see y anymore. So no more y. Okay, so now you turn the equation into an equation containing x and u only. That's what you are doing. So plus, and then x squared. So dy, what is dy? Dy is u dx plus x du from up here, right? Dy is u dx plus x du, okay? All right, so now let's clear the grouping symbols and simplify the equation. So that is, okay, hang on, okay. My son has music on too loud, so let me tell him to turn it down. He didn't know that I'm teaching. Right. So now you can just multiply out. So what you have is u squared x squared dx plus ux squared dx. And then over here, you get x squared u dx plus x cubed du equals 0, okay? So we have, now we're gonna gather all the terms containing dx. So we have this term, this term, this term, and this term. Okay, so we're gonna put them together, but all of these right here, all of them have x squared in common, right? So we're gonna factor out, so we have x squared, u squared, plus u, oh, wait a minute, this one right here. These two give you 2 of them, right? So that's 2u. Okay. And then you have x cubed du equals 0. Okay. So we're gonna try to solve this one by separating the variables. Okay. So we're gonna get the dx. So you're gonna let's move that term to the right. See, I'm doing extra steps here. Dx. I'm trying to find out what u is, so that's why I keep the u on the left hand side. So from here, I have 1 over u squared plus 2u du. And on the right side, I get negative 1 over x dx. All right. And then I'm going to integrate both sides. Integrate both sides. Now, the left-hand side is a rational function, so I'm going to factor out the right-hand side is easy. You have negative here. Let's do that negative. So on the left-hand side, you have to do integrate that by using partial fractions. Okay, so you do it however you like to get the partial fractions, but I'm gonna do it mentally. Okay, so here's how I would do it. Okay, so I say, well, it's gonna be something plus something, right? So I want a u here and a u plus 2 here. But when I try to combine these, so I look at this one as an imaginary 1 and a 1, okay? So if I combine these two, I would have u plus 2 here and a u here. Okay, I have u plus 2 and a u, and I don't want to have a u. I want to have a 1. So I'm going to make this one a minus. Okay, so when I make it a minus, you see, so when I make it a minus, then up here, I have u plus 2, and here's u. So u plus 2 minus u is 2, right? So when you combine these two, you get 2 over u and u plus 2. But on the left side, my fraction has a 1. So I don't want a 2. So to get rid of that 2, then I just multiply everything by 1/2. And I put a 1 and a 1 here, and that should work. Okay, so that's how I get the partial fractions when the denominator is simple like this. All right, so that's how I got the partial fractions. Okay, so now on the left-hand side, I have 1/2 times the integral of 1 over u minus 1 over u plus 2 du. And on the right-hand side, I get negative ln of the absolute value of x plus a constant. I'm going to call it c sub 1 for now, okay, because there might be more constants involved. So on the left-hand side, we have 1/2 times ln of the absolute value of u minus ln of the absolute value of u plus 2 equals, and then on the right hand side you have negative ln that, right? And then you can multiply 2 to both sides, okay, to clear. When you multiply 2 to both sides, then on the right hand side you have negative 2 ln of that plus, and then 2 times c sub 1 is going to be like c sub 2, right? So c sub 2 is twice c sub 1. Now on the left hand side, I can combine these two logarithms together by using the quotient rule. So that is ln of the absolute value of u over u plus 2. Okay, so so this is just pre-calculus. So from here on is pre-calculus. Your goal is to get the u by itself. That's all. Okay, so once you have this, so now you need to get rid of the ln. So on the right hand side, no, let's just leave it like that for now. Okay, how do you get rid of the ln?
You exponentiate both sides.
Exponentiate both sides. Very good. So you're gonna do this and do that, right? Exponentiate both sides. So on the left-hand side, you have the absolute value of u over u plus 2. On the right-hand side, I can rewrite that by writing the negative 2 inside, which is that. Okay, and then plus c sub 2. Okay, and they are still in the exponents, right? And then now I can get rid of the absolute value on the left. So if I get rid of the absolute value on the left, then I should have a positive and a negative like that, right? And then this is, so here you have e raised to a sum of two exponents. So it's going to be the like e to this times e to that. Okay. So e and ln cancel out. So u over u plus 2 is equal to positive negative e to the c sub 2 times the absolute value of x raised to the negative second power. Now, so let's make it, let's do some scratch work over here. This is this. But since you are squaring, okay, so the whole thing is going to be positive anyway. So you don't really need the absolute value because regardless of whether x is positive or negative, when you square it, you still get a positive number. So that is actually this. All right. Okay. So we're going to go over here and rewrite. Now, everything here is just a constant. Do you agree? Just a constant. I don't know, there might be another c involved, so let me just use c sub 3 for now, okay? And then times 1 over x squared. All right, so how do I get the u by itself? Well, now just cross multiply. So you have x squared u, and on the right you have c sub 3 times u plus 2. So that is x squared u, and this is c sub 3 u plus 2 c sub 3. Okay. And then you're going to move all the terms containing u to one side. So it's going to be x squared u minus c sub 3 u equals 2 c sub 3. So u is equal to 2 c sub 3 over x squared minus c sub 3. Right? So basically, it's just like 2c, right? So you don't have any more constant involved. So this is u. So x squared minus, okay. So what is the solution? Remember, when you have a differential equation like this, then it is understood that x is the independent variable and y is the dependent variable. And when you want to solve this one, you want to find out what y is. That's what you are trying to do. You're trying to find out what y is. Okay. So what is y? Y is u times x. And you just found u. So you know the general solution is, okay, so the general solution is y equals u times x implies, let's write, so it is 2c over x squared minus c, everything here, times x. So if you want to write nicer, you can write like, next time so you can write, so y So cross multiply. So you have x squared minus c times y equals 2c x. Please don't write 2 times c as another constant, okay? Because you want to have only one constant involved in your general solution, which is the letter c. So you want to leave it that way, okay? So here you have an implicit solution. If you want to keep it in explicit form, okay, or then you can have this, or 2cx and then x squared minus c. That is explicit, right? So it doesn't matter which form you have, okay? So that's what this section is all about, okay? Making an appropriate substitution, okay, and solve. Now the next example, you have an initial condition. So you need to use the condition to find out what the constant c is. That's what it is about, okay? But from here, the problem, I think somewhere in the direction in the book, it says that m and n are homogeneous functions, okay? So from here, you know that this is m, right? So that's m. And that is n. All right. So which one is simpler?
M.
M. Okay. So you say implies m is simpler. Okay, so if m is simpler, then what kind of substitution would you use?
X is Vy.
Then you let x be, you can use Vy or Uy, it doesn't matter, okay? So x be, if you use V, then so what is the objective here from here on? So from here on, what do we want to find? Okay. You made this substitution for this example. So what was our objective?
Just
U.
To find the u, right? Because if you can find u, then you get your solution here. Y is equal to whatever u is times x. So here, what is our objective?
To find V.
To find v. And you want to find out what v is. And if you can find out what v is, then we get our solution. Okay. So to do that, you're gonna go over here. You make the substitution. Okay, so you have y. So anytime you see x, you have to replace x with vy and so on. So the derivative of x or dx is v dy plus y dv. Okay, and then plus x is vy, and then times ln. I don't like to write the. Let's change the L right here because sometimes we use absolute value and we don't want to mix up with the absolute value. Okay, so ln of x, which is vy, minus ln of y minus 1 dy equals 0. Okay, so that is the substitution that we made. Okay, so this gives you, so let's multiply everything out. So you have yv dy plus y squared dv, and then inside ln of v, y is ln of v plus ln of y, and then minus ln of y minus 1. So we can cancel out these two, okay? Okay, so you see from the last example, you know that after we made this substitution, now we try to separate the variables, right? So we're going to try to solve by separating the variables. So you can make a note of that, okay? So for this section, when we make after making an appropriate substitution, we would like to separate the variables and solve, okay? So make that note somewhere in your notes. And then you have like yv ln of v dy, and then vy times -1 is minus yv dy equals 0. So I see 3 terms containing dy. Okay, so I see 3 terms. This term, and that term. We're going to combine them, okay? But let's see. Oh, never mind. Never mind. I can cancel out this one and this one, right? Oops. So now we can separate the variable. Okay, so we have v. So we're trying to solve for v. So we want to keep the dv on the left. So y squared dv is on the left, and then we move yv ln v dy to the right. And then we're gonna move, so that's gonna give us 1 over v ln of v dv, and on the right we get negative y over y squared, which is 1 over y dy. All right. Okay. So now we're going to integrate both sides. Okay, so let's go to the right side. The one on the left-hand side, on the right side is easy. That is just negative ln of the absolute value of y, right? Plus a constant c. The integral on the left, how would you integrate that? How would you integrate
U
this?
sub. U sub.
Okay, what kind?
U equals ln v. Or yeah. And
So
then
you let u equals ln v.
yeah, and then du equals 1 over v.
1 over v
dv.
Good. So that integral is actually 1 over u du, right? Which is ln of the absolute value of u. Okay, so that is ln of the absolute value of u, and u is ln of v. Okay, you don't need to add a constant here, because the constant, whatever you add, you move it over here, it's going to be absorbed in this constant, so it is unnecessary. Or if you want to, if you're not sure, you say, okay, I'm going to add a constant here. Okay, it's redundant. Okay, you know that when you move it to the right, they're going to be combined. All right, so what do we have? So from here, we're going to move the ln's to one side. Okay, so we're going to move ln. We have ln of ln absolute of v, and then plus ln of y And on the right-hand side, you get C sub 1 minus C sub 2, which is a constant, okay? So from here, we can combine these two. So that is ln of the absolute value of the product, right? Of the product of y times ln of v. And on the right side, you get a constant, C sub 3. So now you can exponentiate, right? Both sides with base e. So when you do that, this one and this one cancel out. You get this. And so c to e raised to c sub 3 is going to be a new constant. Let's say c sub 4. Okay. And then you want to get rid of the absolute values. Then you're going to have y ln of v is equal to positive or negative, and then c sub 4. All right. Okay. If you want to find out, let's find out what v is. So v, what is v? So ln of v. Now positive and negative c sub 4 is going to be a constant c. Okay, so that's going to be a constant c over y. Okay, so v is e to the constant c divided by y. That's v. All right. So you can write like that. Or right here, you can leave it right here, and you know v is x over y. You can even put it right here, right that stage. V is x over y. You can put it in there, and then you can plug in the values to find out what c is, and then your general solution is going to have just y and x, or y and x, right? Okay, but if you didn't see that, you can just do this, and then now you plug it back into this. Where is that? Right here. Okay, so from here, so the general solution is y out x equals vy implies x equals y times v is e to the c divided by y. Okay, so now the initial condition is y of 1 equals e. Y of 1 equals e implies when x is 1, y is e. Okay, now you see y is e. So you see how complicated that is to find out what c is in this case. Okay, you can still do it, but if I were you, I would do it right here. Let me okay, right here. This is where I would find it. Okay, so you make a note right here. You said, well, it takes too much time to get the c. So instead, you could do this. Go back from up here. So right here, you see that is ln of v, which is x over y. Equals c over y. Okay? You see how easy to find c here. So when so y of 1 equals e implies ln of 1 over e equals c over E. Okay, so ln of 1 over E is ln of 1 minus ln of E. And ln of 1 is 0. Ln of E is -1, so that's 0 minus 1. So C is equal to -E. You see? So C is equal to -E. So it's faster that way, right? Okay, so you know, so therefore, you see, this is easier. So because if you have C, you plug it in here, you get your particular solution. So it's faster that way. Instead of over here, you have to find out what C is, and then you have to go over here and replace V with C, and then you plug it in here, and it may not look as good. Okay, but that's fine, because if you try to solve for C here, it's going to be -E also. So if it is -E, then you know V is E to the -E over Y. So you put E to the -E over Y here times Y, then that's your particular solution. But I think this one over here is easier. Okay, so therefore, the particular solution. Okay, so let me write down here. So from here. So therefore, the solution of the IVP is ln of x over y equals C, which is -E over y. Or you can, if you don't want to deal with fraction, you can write y ln of x over y equals -E. Okay. You may want to write the particular solution. Right? Okay. All right. Let's stop right here. I will continue the section, the rest next time. But I want to, now you have about 10 minutes. You can get this ready and turn it in. So turn this in. Oh, it should be 2.2, right? Not 1.2. Okay, so hold on. Okay, and then next Wednesday we're gonna have an in-class quiz on these. Okay, so let me go to. So you should. Okay, so now go to your Canvas and open up Canvas and click on quiz 3B, and then it will tell you what to do. Okay. I'll be right back in 1 minute. Okay, I'm back. So just in case you didn't notice, my running nose went away, right? Because I did a few math problems, then it would go away. Okay. It is afraid of math, I guess. Okay. So you guys, did you guys have any difficulty opening the quiz?
So, Professor?
Yes.
So is this quiz proctored?
No, this is your homework.
Oh, so we're just submitting a PDF through Canvas.
Yes, scan all your homework. Did you click on the quiz?
Okay,
So
okay.
give you the instruction there.
All right. Thank you.
Okay, so make sure you follow the instructions. I tell you exactly what to do. And also yesterday I sent an announcement to you guys, right? On what to put on the upper left-hand corner. So make sure you do exactly what I asked you to do, okay? And as soon as you submit your homework, then you're free to leave. And I was enjoy your holiday, okay? So if you're behind, try to catch up, okay? And then I will see you back next Wednesday for, and we have a quiz on the first 3 sections of chapter 2.
Wait, sorry, you said we have a quiz next
3B.
Wednesday on sections 2.1, 2.2, and 2.3?
Yeah, that's for next week.
Okay, thank you.
Right here. Okay.
Professor, inside the bracket, it should just be quiz 3B, right? Not quiz 3B homework 2.2.
Yeah, either one, okay? If you like quiz 3B homework 2.2, that would be even better, okay? But quiz 3B should be enough.
I'm sorry, I'm really confused. Where are we supposed to see this quiz?
It's in Canvas.
I don't see it.
How about the rest? Are you able to see it?
Yeah, it's in the assignments.
Yeah, it's in the assignments. That's where you do all your quizzes, right? You click on the assignment.
Thank you. Thank you.
Okay, you got it?
Yeah, I see it.
Right here.
So is it just all of section 2.2?
Yes, everything that I assigned in section
Okay.
2.2. Okay, so make sure you read the direction and do exactly what I asked you. Otherwise, you're going to lose points. Okay. So how many prompts are assigned total for 2.2?
10.
10. So how many, whatever you did, put that over 10 on the upper right-hand corner, left-hand corner, sorry. So what I'm going to do is probably I might pick one problem. Yeah, pick one problem to grade for 5 points, and then the rest 5 points for following instructions. Okay, Walid. How come your camera is off?
Sorry about that. I was just taking pictures of my homework.
Oh, okay.
Sorry.
Okay, and remember, make sure it is a PDF, all right? Okay, it has to be a PDF.
If we've submitted it, can we go?
Yes, yeah, as you know, once you submit it, you can leave.
Okay, thank you, Professor.
Have a
Okay,
good
no
weekend,
problem.
Professor.
Yeah, enjoy your weekend.
Oh, I'm a professor.
Yes.
So once I have the PDF file, where do I turn it in? Just in the Canvas inbox?
Yes.
Not on the actual quiz. You
No,
don't have
in
to do.
this inbox.
Okay, thank you.
You're welcome.
Hey, Professor.
Okay, yes.
The program I'm using, it's not letting me change the name. I already had it as homework 2.2. Would that be okay to turn it in as, or?
It should let you. It should let you change. Which app are you using?
Adobe Scan.
I don't. Anybody else using that and have the same problem?
I think.
Yes. You should put it on your computer, and then you can change on your computer. I'm doing that right now.
Oh, it's still taking like forever to upload. It hasn't uploaded yet.
Oh, so
yes, it's gonna take time. So
yeah. So maybe that's not a good app to use. I have used ScanBot, and I never have a problem with that.
Okay.
What do you want us to label the subject or the message?
Just say quiz 3.
I accidentally turned in my 2.3 and not 2.2. Can I turn it in again?
Yes.
Okay, thanks.
Yeah, it changed. Yay.
Oh, thanks for saying that. I didn't notice. I was gonna do that too.
So if it's several pictures saved as several PDFs, they're all supposed to have the
supposed to be
same
one
name?
file.
Okay, so we put them all in like one document,
Yes.
and then okay.
So now I'm doing this on purpose, right? Because it's a homework. It's okay if you can turn in a few minutes late, so you know how to scan your work and stuff. But when you take an actual quiz, when you have only one page or two, make sure you know what to do. Okay.
I did my work on my iPad through an app, and it's like taking really long to convert to PDF.
Well, then whatever it takes, you have to convert it into a PDF and send it to me. Which device are you using?
I'm using my iPad, and I'm currently
iPad? Is it OneNote? You're using OneNote?
I'm using Notability.
Oh, I never use that, so I don't know.
Yeah, normally it works like really fast, but I think people are using my Wi-Fi.
Does it have to be scanned, or can it be a picture?
It cannot be picture because it has to be PDF. Otherwise, I will not be able to grade because I'm gonna write it on there, just like how I grade your physical papers.
So
Thank you, Professor.
if it's a picture like with color, not in black and white, but as a PDF, would that be okay?
Yeah, as long as it is a PDF.
Oh, okay.
Yeah, because I need to grade your paper, because if you send me a picture, I can only look at it. I cannot grade.
thank you, Professor. Bye-bye.
Bye-bye.
And Happy New Year.
Thank you. Oh, Happy New Year to you guys too. I forgot about